Okay, it's 1:30 now. We can start. Hello? Yes. Okay, guys. So what we did so far, we finished data transfer instructions, okay, and we did one lab and the quiz on this one. Also, we finished last time arithmetic instructions. Today, I'm gonna teach branch and loop instructions. Okay. So let's see. Let's start. So here, so what we did so far is something like that. You execute one instruction, and then you execute another one, and then another one. That's what we did so far. Okay. But as you know from programming, that's not always the case. In programming, sometimes I need to loop back. For example, loops. Okay. Sometimes I have a piece of code, and when I want to execute this piece of code, for example, 50 times, 40 times. Okay. So it's not always I have to execute one by one this way, instruction by instruction this way. Sometimes I have to loop. Okay. For example, 50 times, whatever. Okay. So that's what we call looping. Okay. So in this section, I'm gonna explain how can we loop. Okay. The second thing also, sometimes we have branch instruction, something like that. Okay. If A is greater than 5, then go to next. And this I put here next. Okay. So I have a condition. If that's why it's called a branch, because you make like a branch. Can you see this branch here and here? You make like a branch. If the condition is true, I'm gonna go this way. If the condition is false, I'm gonna go this way. Is that okay? Again, what I'm writing here, this statement, if A is greater than 5, this is not assembly. Okay, I'm explaining that in programming in general, we need branches, something like that. Okay, so that's what I'm gonna do in this section. So in this section, I'm gonna explain how can we make loops. Okay. Also, I'm gonna explain how can we make statements like this one. Okay. Any question? Okay. So, by the way, sometimes I say jump instruction. Sometimes I say branch instruction. So they are the same. There is no difference. I just in some microprocessors they use the word jump, in other microprocessors they use the word branch. So if I say branch or jump, they are the same. Okay. So here I want to make a classification to branch instruction. So branch instruction, that's what I'm going to teach now, okay? But I want to make a classification. I want to show the big picture first before I give you details, okay? So the branch instruction I'm going to teach, some of them conditional, some of them unconditional. So I want to define what I mean by conditional and unconditional. Also, some instructions are long, some instructions are short. Some of them are signed, some of them are unsigned. So before I teach the instruction, I'm gonna make some definitions now, okay? So let's start with conditional and unconditional, okay? So I'm gonna teach you two types of branches. One of them called conditional, the other one is called unconditional, okay? You can tell from the English name, so it's not difficult to guess what these branches are doing. You can tell from the English name. So from the English name, in case of conditional, there is a condition. There is, as you see, something like that. There is a condition. And if the condition is true, the branch is taken. So I'm gonna come to here. So I'm not gonna execute the code here. I'm gonna jump to here, okay? Or I'm gonna branch to here. And if the condition is false, so I'm gonna go this way, okay? That's why it's called conditional, because the branch is conditional. Okay, I'm not gonna branch all the time. No, it depends on the condition. If the condition is true, we are gonna branch. The branch is taken. Otherwise, the branch is not taken. That's why it's called conditional, because it has a condition. Is that okay? The other instruction I'm gonna teach, we call it unconditional, and you can tell from the English name, it's unconditional. Unconditional means all the time, the branch is taken. There is no condition all the time. Okay. Someone can ask, or sometimes someone can ask, okay, if all the time you are gonna jump, so why you put a code here? If this code, It's not gonna be executed and all the time it's gonna be jump. Okay? No, it's somehow it is different than that. So I'm gonna explain now. For example, guys, if A is greater than 2, I wanna execute this code. Otherwise, if A is not greater than 2, I'm gonna execute this code. You got what I'm saying? So if this condition is true and I come this way, okay, so I already execute this one because A is greater than 2. So if you already execute this code, you should not execute this code all the time. That is why here, I'm gonna write unconditional branch here. You got what I'm saying? Because all the time, if you execute this part, you should not execute this part. Because I have to explain one thing. I'm just explaining one case, why sometimes we need unconditional instruction. Okay? Because once I come to here, once I do this part and part here, I have to skip this part. Okay? Is that clear? Because I want to execute this part if A is greater than 2. I want to execute this part if A is not greater than 2. So if I don't write this instruction, if I don't write the branch instruction C, you know what's going to happen? You're going to execute the weakest. You're going to move to the weakest. Okay? This instruction. So always, you're going to execute this part and this part. Sure. So in this case, I have to put here unconditional branch instruction. Okay. Anyway, I'm gonna explain later in details about this. For now, I'm just making definition so that later when I teach an instruction, I tell you this instruction is conditional or this instruction is unconditional. You understand what I mean by conditional or unconditional. Okay. Next, also, I here I talked about long and short instruction. Branch instruction. So what do you mean by long branch or short branch? What this means? So that's what I'm gonna explain. Let's first talk about short branch. When I teach a branch instruction and I tell you this is short, what it means? Okay, short branch means, for example, if I write something like that, branch to next, and next is here. By the way, well, I'm gonna use the word next, okay? But this is not a keyword. Sometimes when I use something all the time, students think it has to be this word. No, it's just a name, any name. You get what I'm saying? It's a label. It can be any name. Okay? I just all the time I use this word, but this is an instruction, but next is not an instruction. Okay? Anyway, it's just a name. So what I'm saying here in short branches, here, for example, if I'm here and I want to jump to here, and next is here, or if I'm here, I want to branch to here, okay? There is a limit. There is a limit on where you can jump. How far, there is a limit. How far is this next from this branch instruction, okay? This limit, I'm talking about in case of short branches. This limit is 127 bytes forward. If you branch forward, the limit is 127 bytes, machine code. So if the branch instruction here in memory, if this is the memory and the branch instruction here, so here maximum I can move forward 127 bytes, okay, machine code. Or if you go backward, if you branch backward, so here the maximum is 128 bytes. Is that okay? This is what we call short branches. So conclusion. In short branches, there is a limit on where you can jump. There is a limit, okay? It cannot be, if you have too much code, if you have too much code here, and this code is not more than 128, it's not gonna work. Luckily, the code order is gonna give you error. Because so if you make this mistake, okay, so it's not a logical error. Don't worry about it. Code order is gonna tell you error, it's gonna tell you something like out of range. It's gonna give you a message, and this message is telling you this branch is out of range. Okay. Anyway. So yeah, that's what I'm writing here. Branch is out of range. Okay. Long branch, in case of long branches, there is no limit. You can jump anywhere in the code. There is no limit. Is that okay, guys? So what I'm saying, guys, I'm gonna teach two kinds of branches. One is called short, the other one is called long. In case of short, there is a limit where, okay, so if you have too much code here, and this code is gonna make more than 128 bytes in RAM, Okay, so you cannot, you are gonna get error. You cannot use this instruction. Okay, but for long branches, you can branch anyway. Okay. Okay, guys. So someone can ask me, okay, based on what I taught, it looks like long branches is good. So why I may think to use short branches? Yeah, because this one has a limit, this one doesn't have a limit. So all the time I can use long branches. Why not? You understand what I'm saying? My answer is yes. Look, long branches you can jump anywhere, but if you consider efficiency, long branches are less efficient. That means less efficient means they take more space in machine code is bigger. The machine code is bigger. Also, it's going to take more time to execute the instruction. Okay, but this one is more efficient. So this is one advantage in short branches comparing to long branches. This one is more efficient. Okay, and for what I'm saying, for the purpose of this course, it's okay. All the time you can use long branches. We're not gonna consider efficiency too much. Okay, you are still learning assembly, but just you should understand that short are more efficient. So is efficiency is a big deal for you. Okay, for you can consider short branches. Okay, but for the purpose of this course, what I'm saying, if you have the choice for peace of mind, all the time is long. I'm okay. Is that okay? One more thing. But the reason I'm explaining it here in details because we're gonna have a couple of instructions I'm gonna teach you later. They only short. There is no long version of this instruction. Most of the instruction I'm gonna teach you later, you are gonna have two versions, long and short, and you can use whatever you like. Except only one or two instructions, a couple of instructions, the only short. We have no option. You have to use it. Is that okay? One more thing quickly. It's somehow details. If you don't understand it, that's okay. But just to complete the story, the reason this one is not efficient is because when you use, for example, long branch next, when this one is converted to machine code, okay, so there should be some code for this one, some code, some number. For sure, I don't remember the number. I'm just writing anything. But in addition to the code here, okay, we have to put the address of next. So, for example, if this next as a location 2700, so it's going to be at 2700. So the address, the target address, where you want to go, the location should be above with the instruction. Okay, that's why it's going to become long. Okay, and the way it has to work is when we execute this instruction has to read this part of the memory and it has to put it in PC so that we can go to this location. This is how it works. So how this instruction works, it has to read the address from here. It has to put it in PC. Is that okay? Anyway, again, this is just the details in case you are interested. You are interested to learn more, but that's okay. So that's why this one is not efficient because it's going to take more space for a long address, and also you have to read this address. Okay, the case here is different. In short, it is different. In short, I don't need to put the address. Just to give me the offset. Offset. What do you mean by offset? I mean, if I'm here, if the PC is here, okay, what I should, so PC should equal PC minus offset. Okay, so for example, I have to go back 20 bytes to go to the target location. That's why I don't need to store the complete address. Just to tell me the offset. PC is here. If I want to jump forward, so I have to add 20 bytes or 30 bytes or 40 bytes and so on. That's why I don't need the 16-bit address. Just tell me I need only 1 byte for minus 128 or plus 127. This is what we call offset. Anyway. Any questions? Let me go back. So what I'm saying here, guys, I'm gonna teach the branch instruction. This branch instruction, some of them are conditional, unconditional, some of them long and short, some of them are signed and unsigned. That's what I'm going to explain now, signed and unsigned, okay? Don't worry for now. When I teach the instruction, I'm going to tell you. I'm going to tell you this is short, this is long. I'm going to tell you this is conditional, this is unconditional. Now let's go for signed or unsigned, okay? What do you mean by signed or unsigned? You can tell also, I already, in this course, I explained many times, signed number, unsigned number, same thing, but also here. For example, if I have something like that, if A greater than 2, then I want to go to next. Okay, guys, again, this is not an instruction. This is just, it's just a statement I'm explaining. We are going to do something like that in assembly, but this is not assembly code. But anyway, so when I do a comparison like this one, the question is, do you consider A, register A, the number in A, signed or unsigned, okay? So in order, first I have to check this condition. If this condition is true, we're gonna go to next. If this condition is not true, we're not gonna branch, is that right? So in order to evaluate this condition to see if it's true or not, I need to know if the number here in A is signed or unsigned, because it is different. How? I give you a specific example here. If A has this number 11111, listen to me. So if you consider the number signed, that means this one is -1. 11111 is -1. And in this case, -1 is not greater than 2. Is that right? So the branch should not be taken. But if you consider this one unsigned, A should be 255, which is greater than 2. So the branch should be taken. So it matters, right? I need to know, signed or unsigned. Is that okay? Because it's going to be different. Okay, guys? So when I teach instruction, I'm going to tell you this instruction for signed, this instruction for unsigned. And then you're a programmer. When you write your code, you know, you already from the beginning, you decide if this number is signed or unsigned. So you have to use the correct instruction. Is that okay? So if you consider your number signed, you have to use signed instructions. If you consider unsigned, you have to use unsigned. This is similar to what I explained last time. You remember division, diff S, multiplication, emal S. So we have two sets of instruction when it matters, when the sign matters, when sometimes it doesn't matter. For example, in case of load, store, move, you just copy bits. It doesn't matter if it is signed or unsigned, right? But when it matters, like here in these conditions, for sure you have to give me two instructions, two different instructions, one signed and one is unsigned. Same thing for multiplication. It matters in multiplication and division. So that's why also we have two sets of instructions. Any questions? Okay, guys. So now let's start the details, but so now what I'm saying, I'm going to teach now branch instruction. When I teach branch instruction, we have conditional, unconditional, we have long, we have short, we have signed and unsigned. And you should now understand what this means. But for sure, the details are coming. This is just a big picture. Now let's see the details. Number one, conditional or unconditional. Okay, we have many conditional instructions, but for unconditional we have only one instruction for unconditional. Okay, guys. So if you want to make unconditional branch or jump, again, don't be confused. Branch or jump, the same thing. Okay. I will do my best to use the word branch all the time, but sometimes I use the word jump because in other microprocessors they use the word jump. Okay, so sometimes it's difficult for me to focus on branch all the time because I used to jump before. But anyway, so here for unconditional instruction we have only one instruction, only one. Look here, guys. BRA, branch. This is the instruction we have. And next to branch, you have to write a name. This is where you have to jump. And this label or name, you have to put it in your code. Okay. So, and look here, guys. If you add here letter L, LBRA. So now this is the version for long. And this is always the case. Always the case. When I give you one branch instruction, if you add letter L, it becomes long. Is that okay? So what I want to say for branch, so this is the instruction we have, BRA, but without L, so this one is short. With L, it's long. Okay? So this is long branch, this is short branch. Okay? So, for example, here I'll just give you one example as we are gonna do in as we are gonna do in chapter 3. I want to make a flashing LED. So here I have one LED. I want to make it flashing. Turn on, off. That's what we are gonna do in chapter 3. So the way I'm gonna do it, I'm gonna turn the LED on. I'm gonna write instruction to do that. Then I'm gonna wait 1 second. So I'm gonna keep it on for 1 second. Then I'm gonna turn it off. So I'm gonna wait 1 second. Then I'm gonna loop back to the data here. Okay. So the way you can loop back, you can write here BRA begin or LBRA begin, so that you can loop back here. And for sure, you have to use the word here. So it's the same word. You have to put it here. So you name a line. So I have to name this line of this instruction so that I go back here. Okay. Again, begin and next are not instruction. They are names. You can write your name. Just names. Okay. Any questions here? So this is for unconditional instructions. Okay. Any question? Okay. So let me have a table here. I want to show the table. Yeah, here. Yeah. So these are all the instructions we have for branch. Okay. And you can see here, guys. Don't worry, I'm gonna explain everything. But these all branch instructions we have. These instructions here are for conditional. I'm gonna start explaining them. These are conditional, and this is the only one I accept. Unconditional. This one here. Okay. As I said, it has two versions: BRA or LBRA, long and short. Is that okay? So this one is gonna branch always, all the time. It's gonna branch unconditional. Is that okay? And all of these instructions, like that's what I'm going to explain right now, are conditional. And also you can see here, guys, for every instruction, we have two versions. One with L and without letter L. You can see here, look. BCC, LBCC, this one. So you can see always we have one version here, short version, and we have long version. And they are exactly the same, but we add letter L at the beginning. Same thing here. Okay, same thing here. Same thing here, same thing here. But is that okay, guys? For sure. Don't worry, I'm gonna explain all of this, and if they are not difficult, I'm gonna explain all of them. But for now, for every branch instruction, we have two versions. One with letter L at the beginning, and another one without letter L. Okay, so L means long. Without letter L means short. So for all this instruction, luckily, for all this instruction, we have two versions, long and short. Okay, and again, my advice, just for peace of mind for now, again, you already know what is the difference between short and long. You may need it in the future, but I think for the purpose of this course, just to make things easier, for this instruction, all the time use long. I'm okay. You're not gonna have any problem, just use long. Okay. But as I said, just later I'm gonna explain. We just have a couple of instructions, we only short. Okay. Any questions? So now I'm gonna teach this instruction here, conditional, guys, conditional instructions. Okay. So let's start with something in the beginning. There are many instructions, but once I teach them, they are not difficult. I'm gonna tell you why they are not difficult. Okay. I mentioned this one before, but I'm gonna repeat it because I need it now. How can you make a condition like this one? Okay, guys, if A is equal to 2, go to next. Okay, so I wanna make a condition like this one. So the branch is gonna be taken if the condition is true, otherwise it's not gonna be taken. Is that okay? How can we do something like that in assembly? How can we do comparison in assembly. Is that okay? I explained it before. The way I have to do, in order to do something like that in assembly, guys, I have to use two instructions. Two instructions. The first instruction, I have to do subtraction. So here I'm gonna subtract 2 from A. Okay? Because once you do subtraction, you are gonna update the flags. This is number one. You remember I explained this one before. So number one, you have to do subtraction and then to update the flags. And then next one here, so you have to use two instructions together, two instructions. One subtraction to update the flags. Second one, you have to use one of the branch instructions that we are going to teach now. Okay? And this branch instruction are going to look at the flags. And based on the value of the flags, you are going to branch or not. For example, in this specific example, look here, guys. When I subtract, okay, and now I want to branch if it is equal. If it is equal, then branch. So this branch instruction is going to look at the 0 flag. Because if the 0 flag is 1, that means A is equal to 2. The branch should be taken. You got it? So the conclusion is, in order to make conditional branches, number one, you have to use two instructions. One instruction is you have to subtract and to update the flags. This is number one. Okay. Number two, you have to use one of the branch instruction. And this branch instruction, what branch instruction is going to do? Number one, they are going to check the flags and then jump on the based on the value of the flags. For example, I have one branch instruction I'm going to explain right now. For equal, we have one branch instruction. This instruction, all what this instruction is going to do, this instruction is going to look at the 0 flag. If the 0 flag is 1, it's going to jump. Otherwise, it's not going to jump. Is that okay? That is why, before I use this instruction, I have to set the flags first. Because this one is going to just look at the flag. It's going to jump or not based on the values of the flag. So that's why, before I use this one, I have to set the flags first. Is that clear, guys? Any questions? Is that clear? So here for equal, I'm gonna look only at one flag for equal. For greater, for less, for greater or equal, less or equal. So here you are gonna look at other flags. But it's the same idea, but you are gonna look. I just here explain the easy case so that you can understand the concept. Is that okay? But for greater, for less or equal, greater or equal, it's the same idea, but you're not going to only look at the 0 flag. You may look at the 0 flag, but you are going to look at the other flags. It's the same idea. Is that okay, guys? Okay. Okay. So the conclusion is that if you want to make a conditional condition, what you have to do, number one, I have to do subtraction. Not because I'm interested in the difference. No, I'm not doing subtraction for subtraction. I don't care about the difference. You got what I'm saying? This difference, the result, I don't care about the result. I'm doing subtraction because I want to update the flags. Why you want to update the flag? Because after this instruction, you're going to use one of the branch instructions that's gonna look at it. It's going to branch not based on the values of the flags. Any questions? That clear? Okay, but okay, so you are telling, but there is a small problem here. What is the small problem? If I do subtraction, I already explained subtraction last time, okay, or the lecture before. So I already explained we have subtraction. Can I use subtraction here? It's okay, you can use subtraction, but there is a problem here. What is the problem? If you do subtraction, the result is going to be stored in A. You remember? So if you do subtraction, A should equal A minus 2. So you're going to change A. And keep in mind, here I don't want to do, I don't care about the difference. Okay? All what I want to do subtraction, update the flags, and don't store the difference anywhere. Okay, guys? So that's why they invented, they made another instruction. It's called compare instruction. Okay, compare instruction is similar to subtraction. It's same thing like subtraction. Okay, but there is one difference. The difference is that the result is not going to be stored anywhere. You got what I'm saying? Is that clear, guys? So here, in compare, I'm going to teach now also compare instruction. So but for now, you should understand compare instruction is similar to subtraction instruction, subtract. Okay? But they are similar in what? Both of them are going to do subtraction. Both of them are going to update the flex. Is that okay? But subtraction is going to store the result here. Compare is not going to store the result anywhere. Is that clear? This is the only thing. Okay. So if I want to make a condition like this one, guys, this is the way I have to do it in assembly. I'm going to use a compare instruction. Here I'm going to compare register A to 2. When I say compare A to 2, that means this one is going to do subtraction, A minus 2. Okay. And then it's going to update the flex. And this one is not going to change A. Because I don't want to change A. I just want to make just want to update the flex. Is that okay, guys? So I have to use this instruction. After this instruction, I'm going to use an instruction I'm going to teach right now. It's called the branch if equal. Branch if equal. So this instruction, if the zero flag equal to 1, is going to branch. Otherwise, it's not going to branch. Okay, guys, is that clear? So now what I'm going to do right now, I'm going to teach what compare instruction, what instructions we have for compare. Also, I'm going to teach what kind of branch instructions we have. Is that okay? But before I do that, I want to make sure, guys, everybody here in this room understand how can we make conditions, okay, by using two instructions. Okay, number one instruction to update the flex after subtraction. Second one is going to look at the flex, and based on the value of the flex, I can know if it is greater, or if it is less, or if it is equal. Is that okay? Okay, guys. Any question here before I move forward? Okay. So let's teach compare instruction. Okay. So that's all what we have for compare. So here I'm going to say compare A to B. So this one is going to be A minus B. Okay. So we have also compare A to immediate value or memory location. This is going to byte. So A minus immediate value or A minus memory location. So you can compare. That's what we did here. I compared A to a number. Also, you can compare A to memory location. So I can put here a memory location, a byte in the memory, okay? Also, we have compare B, register B, with memory or immediate value, okay? That's all what we have for byte. So here we have 3 instructions to compare byte to byte, okay? Only 3 instructions. For sure, I don't have an instruction to compare memory location to another memory location. We don't have this instruction, okay? Similar to what we did last time, if you want to compare memory location to memory location, you have to take one of them, put it in register A, and then compare register A to the other memory location, okay? Also, we have here 1, 2, 3, 4. We have 4 instructions to compare word to word. So here we have to compare register D, immediate value or memory location. And again, you can use any format of the memory location. I explained several format, and we have used several formats for memory locations, okay? We have to compare X, we have to compare Y, we have to compare S for stack point. This is word to word. So here, this memory location here is a word, memory location here is a word, word, but here they are bytes. Okay, guys, any questions? So all this instruction is gonna do subtraction, it's gonna update the flex, all the flex, but they are not gonna change register A. So here, this one is not gonna change any registers. Any register not gonna change here. Okay? So I summarize them here in one table here. So you can find all of them are here in one table. Here. Okay, guys. We also have test instruction. We have here test instruction, which is exactly similar to compare instruction, But this one all the time is gonna compare to 0 all the time. So here, so it is compare, similar to compare. But this one, if you wanna compare with 0 all the time, okay? So I'm gonna tell you. So we have test instruction. This is exactly like compare, but this time we compare to 0. For example, we have test A. So what test A means? Test A means A minus 0, okay? So this is the same if you say compare A to 0, same thing, okay? All the time 0, yes. Test B, this one is gonna be minus 0. So this one is gonna compare B to 0. Is that okay? The last one here, which is somehow interesting to me, or maybe more useful, I'm gonna tell you why this one is useful. You can say instruction test. And after test here, you have to put a memory location here, and this memory location has to be a byte. So this one is used if you wanna compare a memory location, a byte memory location to 0. For example, I can say something like that, guys. Test 1000. Okay. So what this instruction is gonna do is gonna subtract 0 from 1000, as you see. Okay. Also, the reason I see this one interesting, because if you don't use this instruction, okay, you have to use 2 instructions instead of this one. Okay, at least here in test, if you use 1 instruction, there is only one here. Here 1, here 1. But here, if you don't use test, you have to use 2 instructions here. So I have number 1, I have to read the memory location 1000. I have to store it in A. Okay, I have to load it in A, and then I have to compare A to 0. Is that okay? Simply because we don't have a compare instruction for memory location to immediate value. Also keep in mind, this is for byte. This memory location is a byte. If it is a word, what would I do? If it is a word, you cannot use this one. It's a word, but you can use this one. But in this case, you have to, for example, you have to say load G. If it is a word, you can say load G 1000, and then you can say compare, CBG. Compare G to number 0. This is the result. Any questions? Any question? So let me summarize what I said, guys. What I said, if I wanna make a condition like this one, how I can do it in assembly? I have to use 2 instructions. One instruction to do subtraction and update the flags. The other one, I'm gonna use one of the branch instruction, and this branch instruction actually, they are not doing anything other than they look at the flags, based on the values of the flags are gonna jump or not. Okay. I want to tell you something, guys. In very few cases, you may not need to use compare instruction. Why? I use compare instruction to update the flags. But if the flags are already updated, I don't need it. It's redundant. Okay. But anyway, but this is not the general case. The general case, most of the time we are going to use compare instruction. But during this course, you will see in just very few cases, we are not going to use compare instruction because the flags already updated. Based on the previous instruction, the flags already updated. You got what I'm saying? So I don't need to use it. Okay. For example, as I'm going to teach you later, you are doing addition. When you do addition, for example, there is a carry. If there is a carry, that means it's overflow. Okay. So in this case, you can just check the carry. If the carry is 1, that means there is overflow. So I have to go somewhere to take action. So in this case, I don't need to use compare. Okay. Anyway, so most of the time you can use compare, but the flags are already updated. So in this case, you can just use branch instruction. Any questions? Okay, guys. So here in this table, so this table has all compare, and also test instruction in this table. Okay. Now I'm gonna come to here. Okay. Now I'm gonna teach I'm going to teach branch instruction. As you see here, we have many branch instructions. But I'm going to tell you what is the difference before. Oh, so here for conditional here, guys, we have many branch instructions. But look here, look what is the difference between them. I'm going to tell you what is the difference. These two tables here, these two guys, these two tables are used if you want to make a condition like this one, something greater, for example, A is greater than 2, less than 2, greater than or equal, less than or equal. Okay, if you want to do something like that. If A or memory location or register X or register D, I'm just giving example. Okay, if you want to do condition like this, greater, less, greater than or equal, less than or equal, is that okay? That's why you can see 4 instructions with 1, 2, 3, 4. Because this is 4 and the other 4. And this is 4. But why 4 and 4? I need only 1 4. Why 4 and 4? The reason 4 and 4 because this one for outside. Is that okay? So here what I'm saying, these branches are used if your numbers are unsigned, and these branches are used if your numbers are signed. And these branches are used in case of greater, if you want to make it something like greater, less, greater than or equal, less than or equal. And maybe this also details, you may not need it, but as I said here, guys, here, this one is going to look at some flags. Okay, so if you want to know if it is greater or higher, this is the flags it's going to look at. Sometimes it needs to do some operation with some flags. Like here, for example, this is XOR, OR and XOR. Anyway, so here sometimes, in order to know if it is greater or less or whatever, we are going to use more than one flag. So here we are going to use carry, 0, carry, 0, negative flag, overflow flag, and so on. But anyway, just details. I'm not going to go deeply in this area. I'm not going to teach more here. But this is what I explained. We just can use some flags, the flags to know if a branch should be taken or not. Okay. And now, so here what I'm saying, we have here these two tables are used if you want to make something like that, greater, less, greater than or equal, less than or equal. Okay. What about this table? I didn't explain this table yet. Okay. Yes. This table is we call this table simple branches. Simple branches. Because these branches are gonna look, sometimes I want a branch if the overflow flag is 1. I want a branch if a certain flag or 1 or 0. Okay, so here, so this one is used. If you wanna check the value of flags, and you wanna jump if the value of the flag is 1 or 0. So this one mainly. It's not like this one. This one here is mainly used for comparison, greater, less, greater than, equal, less than, or equal. But this instruction here, as I'm gonna teach, they are used, sometimes you wanna jump if a certain flag is 1 or 0. That's why if you look here, guys, this one is gonna jump if carry is 0. This one is gonna jump if carry is 1. Okay? This one is gonna jump if 0 flag is 1. 0 flag is 0. Negative is 1. Negative is 0. Overflow flag is 0. Overflow flag is 1. Is that okay? So I have all of them, not 8, I think they are 8, right? 1, 2, 4, 6, 8. But all 8. Because we have 4 flags. For every flag, we have 2 branches. One branch if this flag is 0, one branch if this flag is 1. Is that okay? Anyway, so let's see the details now. So here, what I'm saying, guys, we have two types of branches. One of them is called simple branches. That's what I'm going to teach right now. This one is going to branch is if one flag is 0 or 1. Okay, and then we have when you compare 2 numbers, so we have here also some branches for greater than or equal, less than or equal, and under this classification. We have signed or unsigned. Now I'm going to give you details. So let's start with the simple branches. Okay. The first one we have, as I told you, every instruction we have 2 versions, one without L and one with L. Okay. So this one, branch BCC. So for L here means long, as I said. L here means long. B means branch. So this one is branch if carry is clear. C means carry, C means clear. So it's very obvious that this one is gonna branch to next if carry is clear, carry is 0. Is that okay? Here we have branch if carry is set, B, C, S. So this one is gonna branch if carry is 1. Is that okay? Okay. Let's see these two before I come to this one. Okay. Here B, B, C. This one is gonna branch if overflow flag is clear. Okay. Branch of overflow flag is set. Okay. Branch if minus. Minus means the negative flag is 1. Is that right? So this one is gonna branch if the negative flag is 1. Okay. This one branch if plus. Branch if plus. This one is gonna branch if the negative flag is 0. Is that okay? Very easy, right? There are too many instructions, but I think they are easy. The last one here, branch if equal. So here the equal means 0 flag is 1. Equal means the 0 flag is 1. Branch if not equal. So this one 0 flag equal to 0. Right, guys? Because as I told you before, when if I want to compare if A equal to 2, so I'm gonna do subtraction first. Okay. After I do subtraction, okay, I'm gonna look at the 0 flag. If the 0 flag is 1, means they are equal, right? Means A is equal to 2, right? If the 0 flag is 0, that means the result is not 0. That means A does not equal to. That is why here branch if equal, it means branch if 0 flag is 1. You understand the logic? So equal means 0 flag is 1, right? So here branch if equal, branch if not equal means the 0 flag is 0. Any questions? Okay. Don't worry, I'm gonna give you a lot of. I'm gonna teach too many instructions, then I'm gonna give you a lot of examples. Using example, you will understand more. Okay. So before I move forward, let me summarize what I said from the very beginning quickly. Number 1, I said, guys, here, not very beginning, but at least from here. I told you in assembly, in order to do conditions, okay, we are going to use 2 instructions. One is compare, okay, in order to update, in order to set the flags. After compare, you have to use one of the branch instruction, and this branch instruction are gonna decide to branch or not based on the value of the flags. That's why I have to update the flags before I use this instruction. This is number 1. And number 2, I explain several instruction for compare. I explain several instruction for test. I told you test instruction or compare are exactly the same, but test is gonna compare to 0. That's what I explained. Okay. Number 3, for branch instruction, I told you we have one of them is unconditional. That's what I said in the very beginning, unconditional, like BRA, just a branch. Oh, there is no condition. Okay. For sure, I don't need to use compare here because this is gonna branch all the time. There is no condition. Okay. Here for branch instructions, okay, I told you we have 2 types of instructions. One of them we call it simple branches. So this one we have 4 flags. For every flag we have 2 instructions. Jump if this flag is 0, jump if this flag is 1. That's why total we have 8. Okay, under this one. So here that's what I explained. Branch if carry is clear, branch if carry is set, branch if equal. Equal means the 0 flag is 1. Branch if not equal means the 0 flag is 0. Okay. Branch if the B flag is 0. Branch if the B flag is 1. Branch if negative flag is 1. Branch if negative flag is 0. Minus or plus. Is that okay? Now what I'm gonna teach now, the last part here, the last instruction here. Sometimes I have a condition, okay, like something like if A is greater than 2, or A is less than 2, or A is greater than or equal to, or A is less than or equal to. if you want to make a condition like this one, so you have to use this instruction. Okay, 4 instructions. So we have 4 instructions: 1 for greater, 1 for less, 1 for greater or equal, 1 for less or equal, and we're gonna have 4 for signed, 4 for unsigned. So we're gonna have 8 instructions now. Okay. So let's see. These are the 8 instructions we have. Okay. But just to make it easy for you, for sign number, we're going to use the English words greater, less, equal. Okay. For the unsigned numbers, we're going to use another English word. They are the same English words, but like here, higher, lower, same. You got what I'm saying? So here, so when I use greater means we're going to use these 3 words for sign, greater. But higher means it's going to be for unsigned. So let me give you the details. So this is how can you make a condition. Number 1, I have to compare, as I said. So I'm going to compare A to number 2. This number 1. Number 2, then I'm going to use one of these instructions. One of these instructions after compare. The first one here, guys, B means branch. G means greater. E means equal. So this one is going to branch if greater or equal. So branch if A is greater than or equal to. So if you use these 2 conditions together, okay? So I'm going to branch if A is greater than or equal to. Is that okay? Here, branch of greater. Okay, so this one is going to branch if A is greater than 2. Branch of less or equal. Less or equal. Okay. This one, branch if less. Okay, guys? Is that clear? So number 1, you have to use compare. After compare, you have to use one of these 4 instructions. 1 for greater, 1 for less, 1 for greater or equal, 1 for less or equal. Is that okay? Here, yes, there are too many instructions, but they are easy. Okay. Here, I'm going to use exactly same instruction, but I'm going to use different English words, right? Just to differentiate between them. So here, instead of letter G, greater, I'm going to use letter H for higher. Instead of letter here, L for less, I'm going to also use L here. So here, L and L. It's not going to make a difference. But for same, or if they are the same, here I'm going to use E for equal. Here I'm going to use S for same. But you'll see now. So here, this is unsigned number. So here I'm gonna say branch with higher or same. Okay. So this one and this one, guys, this one and this one are exactly the same. But here, this one will consider the numbers signed. This one is going to consider the numbers are unsigned. Compare is the same. It doesn't matter in compare. In compare, it doesn't compare here. Compare again. Compare is going to be just subtraction. If the number is signed with something, it doesn't matter. So again, it's the same compare in both cases. The only difference is that if your numbers are, if you want to do condition bigger than or equal, okay, and your numbers are signed, you have to use this information. Okay, if it is unsigned, you have to use this. And just to make it easy, I told you, just we use different English names. They have the same meaning, but just different English names. Okay. So here, branch if greater, this one should be branch if higher. Things are exactly the same. This is for signed, for unsigned. Branch if less or equal. Branch if less or same. BLS, BLE, BLT, BLO, right? So this one is going to be less. This also less. But this is for signed, for unsigned. Any question, guys? Okay, guys. Okay. So let me here explain what I did and what I'm gonna do right now. What I did and what I'm gonna do. What I did, I explained number 1, compare instruction. Okay, that's number 1. Number 2, I explained branch instruction, different types, different kinds of branch instruction. Okay. I told you to make a condition, I have to use 2, 1 compare and 1 branch. That's what I said. Okay. What I'm going to do right now is, and this is the interesting part in my work. What I'm going to do now is, you remember if statement in C language, right? In C language, we had In C language, we had if statement. We had if else. Is that right? We have a switch case. Do you remember switch case? We have if, else, if. Okay, right? We had for loops. We had while loops. Okay. So the question is that how can we make this statement in assembly? In assembly, do you have if statement in assembly? The answer is no. Do you have if else? No. Switch? No. No, 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 no. We don't have all this instruction in assembly. But using compare and branch instruction together, I'm gonna make all of them. That's what I'm gonna teach. So what I'm gonna teach now, how can we do simple statements like this one using compare and branch? Is that okay, clear? Any questions? So how can we do something like what you did before using compare and branch? Okay, and even you can invent your own statement. Okay, and you can use it using compare and branch. And that's actually what happens in C language when you write this level. If something, okay, when it is converted to machine code, it has to be converted to compare and branch instruction. You get what I'm saying? It's like a building in C language. You were in floor number 10, for example. In floor number 10, you write if statement. Here in assembly, you are in the first floor. First floor, okay? In first floor, this if should be compare, and the branch instruction. Is that okay? That's what happened. In C language, when you use if statement, this if statement is gonna be converted to compare and branch. Okay, any questions? So that's what I'm gonna do in this lecture and in the coming lecture as well. I'm gonna teach how can we use compare and branch instruction right now to make this statement. Okay. You know, this section is very important. You know, any program should have one of these statements. It's a very in any programming language. These statements are very important. Okay, any program, all the programs should have these statements. Okay. Number one, I want to teach in assembly how can we do if statement, something like that. So number one, I'm going to explain the statement in C language, and then I'm going to teach how can we do the same thing using compare and branch instruction in assembly. So start with the first one. I want to do something like that, guys. If I or A, whatever, doesn't matter. If A or I equal to 1, so I have to, and then you have braces here, okay, and then you have statement here or set code here. This code I'm gonna call it S1. So I have code here S1. Okay. Number one, how this statement works in C language before I talk about assembly. The way this should work in C language is you have a condition. This condition can be true or false. If this condition is true, I'm gonna come here inside the body of if, I'm gonna execute S1. So S1 is sequence of instruction. I'm gonna call it S1, okay? If the condition is false, I'm gonna come to here, okay? So if I does not equal 1, the condition is false, so I'm gonna come here. In other words, I should execute the sequence S1 just in one case if the condition is true. Otherwise, don't execute it. S1. Is that okay? How can we do something like that in assembly using the same logic? Same logic. Okay. Look here. I assume here again. It doesn't matter if I or A, but here I assume I is a memory location. Okay. So here I'm gonna say load accumulator A with I. So now I'm gonna use register A because I cannot compare. I don't have compare instruction for memory location and immediate value. That's why I'm gonna read it and put it in register A. And then look here, I'm gonna compare it to 1. This number 1. So I'm gonna compare this value to 1. Okay. Look what I did. And then I'm gonna say a branch if not equal. So if A which is I, same thing. Okay. So if A does not equal 1, come here. End if. something, just again, it's just a name, any name. So I'm gonna skip. So I'm gonna skip this part. This part here should be S1. Same thing like this one. So here I'm gonna skip S1 if A does not equal 1. But if A equal to 1, I'm gonna come this way. It's the same logic. What's the same logic? In both cases, if it is equal to 1, I'm gonna execute this one. Here, if it is equal to 1, so this branch is not gonna be taken. This branch is gonna be taken. It is not equal. Okay, so I'm here. I'm gonna, if they are not equal, I'm gonna come to here. If they are equal, I'm gonna come to here. That's why we call it a branch. Right? So if it is not equal, I'm here. If it is equal, I'm here. Okay. So, in other words, the only way to execute S1 here is that this branch is not taken. Because if this branch is taken, so I'm not going to execute S1. The only one to execute S1 here if the branch is not taken. And the branch is not taken if they are actually equal. If the condition is true, they are equal. Okay, guys? Any question? You can see here the logic here and the logic here. This logic. Any question? Okay, one more thing I want to explain, also very important, guys. Someone can tell me, but this condition was equal. But when you decided to use branch, you used not equal, the opposite of this condition. Yes, the logic is true. Yes, the logic here. So the logic means S1 here is going to be executed if I equal to 1. Same thing here. S1 is going to be executed if E equal to 1. So the logic is true. But tell me why you make it this way? Because here it is equal. The condition here is equal. But when you did here, we used to not equal. Is that, you got what I'm saying? So if I were you, I would first think about equal, to use equal, similar to this one. Yes, number one. This is programming language. You can use equal and it's gonna work. But maybe it's gonna be more complicated. More complicated means you have to use more instructions, but it's gonna work. This programming language. So what I want to tell you, sometimes if you try to make the opposite of the condition, you can make it easier. You got what I'm saying? But what is important, the logic has to be the same. Regardless of anything, the logic has to be the same. But to do the same logic, you have option. The option we have, I can use equal and I can use not equal. Okay? You can think in both and think to try to see which one easier, right? Sometimes the opposite of the condition is easier. Okay, so here I did the same question but using equal, just to make the point clear. So here, if I use equal, so I'm gonna come to here, guys. I'm gonna compare A to 1, and if it is equal, go to what we call body, the body of F. And this is body of F is here, and this is S1 is here. Okay, but if it is not equal, if I come to here, that means if I come here, I'm gonna come to here if it is equal. Here, if A does not equal 1. If A does not equal 1, so here I have to put another condition here to skip this part. Listen to me, it's very important. Okay, so what's gonna happen, I'm gonna compare A to 1. If it is equal, so I'm gonna come to here to skip this one. If it is not equal, so the branch is not gonna be taken, it's gonna go this way. Okay, that's why here, if it's not equal, I have to skip, because if I forget this instruction, it's gonna go the way this way. Very important to understand this. Very important. I'm quite sure, at least in the beginning, you will make these mistakes. I'm quite sure of this mistake. Look what is the mistake. Look here, guys. If A is equal to 1, the branch is gonna be taken, I'm gonna come to here. That's okay, this is okay. But if A does not equal to 1, so this branch is not gonna be taken. So I'm gonna go this way. That means I'm gonna if I don't put something here, you are gonna execute S1 regardless. All the time you're gonna execute S1. You understand what I'm saying? And this is a common mistake. If I delete this one, again, this is a common mistake. If I delete this one, that means if it is equal or not equal, you are gonna execute S1 all the time. the logic is not going to be true. It's not going to be the same logic. Okay, that's why I'm quite sure at least in the beginning you may make these mistakes. Okay, my advice, maybe this topic maybe somehow a little bit difficult, but again, what's important if you use errors, like what I did. Also, if you look at the logic, this is the most important thing. Again, what I'm going to do is the same logic as the same. So I have a statement. This statement has to do something. It should have a logic. Okay? So I'm going to do the same thing in a simply to do the same logic. Is that okay? Logic, what do you mean by logic? I mean, if I equal to 1, I'm going to execute S1. Otherwise, don't execute it. This is the logic. Okay? So write whatever in assembly that can do this logic. Any questions? Is that clear? Let's have more examples. I have more examples. So let's have another example here, guys. If else statement, if A is equal to 1, so I'm going to execute the body of A. Sorry, the body of F. So I'm going to execute S1 here. Else, you remember else? So here in case of else, I'm going to execute S2. Right? You remember what is the logic here from C language? What is the logic of this statement? The logic is, I have a condition. If the condition is true, I have to execute S1. If the condition is false, I have to execute S2. That's it. Is there any case, under any condition, under any case, can we execute S1 and S2 together at the same time, both of them? For sure, no. Because this is what this statement is saying. This statement is saying, condition is true, I want to do this. Condition is false, I want to do this. So this is the logic. So there is no way to execute both of them at the same time. Is that okay, guys? So the question is that, how can we do the same thing? How can we do the same logic using compare and differential instruction? Okay, that's what I'm going to do. Look here, guys. Compare A to 1. If it is not equal to 1, not equal, that means the condition is false. So go to else. So look here, I'm going to come to here. Okay. If A does not equal to 1, I'm going to come here to else. Otherwise, if A equal to 1, I'm going to go this way, right? So the only way to come to else here, if A does not equal to 1, that's great. This is the logic. That's what I want to do. I want to execute this one if it is not equal. Okay, great. So I'm going to put here S2, sequence 2, this part. This part has to come to here. Okay? This part has to come to here. So this is the body of else. This part has to be here. Because I'm going to execute it if it is not equal to 1. Right? So I want to execute this part if A does not equal to 1. Means the condition is false. I want to execute this part if A is equal to 1. That means the condition is true. Okay? So now if it is not equal, I'm gonna jump into here. But what if it is equal? So the branch is not taken. I'm gonna come this way. Okay? So and if A is equal to 1, I want to execute S1. Yes, so I'm gonna execute S1. Okay, guys? But be careful, be careful. If you forget this statement, and again, this is a common mistake. Okay, if you forget this statement, again, guys, this is a machine. Computer don't understand. They do whatever you tell them to do, right? So that means if you forget this one, can you know this what's going to happen? If I don't go to start to do. Let me tell you what this instruction is doing anyway. And then I'm gonna ask why I put it. So what I did after I put S1 here, okay. So S1 here is gonna be executed if A equal to 1. And then at the end, I'm gonna do unconditional instruction to skip this part. So if I come here, so if I execute S1, I have to skip this one. I have to skip it. Okay. Again, this is a common mistake. My question is that I'm quite sure, very important point, okay, and very serious. You know why it's very serious? If you forget this one, okay, why it is very serious? I'm gonna tell you why it is very serious. Because We have two types of errors. We have misspelling, and this is very easy part. Code warrior is going to get you error. Is that okay? We have the second part is logical error. Logical error. Unfortunately, this is a logical error. Logical errors is usually difficult. You can maybe spend 2 hours or maybe something, especially if the program is too long. You run the program, it works, but everything is running, but it doesn't give you the correct result. But I'm saying so something wrong in the logic, not in the spelling. Okay. This is one of the very common mistakes. If you pay attention and you understand it, you may save time, right? To avoid making this mistake. Okay? So what is the mistake? I need someone to tell me if I forget to write this one here, what's going to happen? Raise your voice. Yeah, because no one is going to stop it. So it's going to continue. So after I skip this one, we're going to go to this two. That means what is the new logic? So this is the thing. I have a logic here. I want to program this logic. What I did here, it's a different logic. Why it is different logic? I'm going to tell you why. Because the logic I'm doing here, if A does not equal 1, execute ECE2. Yeah, this is okay. This is similar to this one. If A does not equal 1, execute ECE2. This is similar to this, okay. Okay? But if A equal to 1, execute S1 and S2. That's not okay. Because the logic here, I have to execute is only S1 if A is equal to 1. Is that clear, guys? I'm repeating this part. I'm just focusing on this part because I'm quite sure, at least in the beginning, you may make this error. So what I'm saying, based on the logic here, if I execute S1, I have to skip this part because no one is gonna stop. Your program is gonna go all the way this way. Okay? Because the word else, this is just any English word. It's not gonna kill microprocessor or anything. It's like make it like your name, just a name. It doesn't understand this is else. Doesn't understand what else means. Any questions? Here I give example for equal, guys, but it's very easy to make it greater. It may be very easy to make it less and so on. Okay. I want to tell you something very easy, but listen to me. Because the exam is open book, luckily it's open book. That means in your exam, if you need if statement, you can go to the slide here and see how to make if statement. That's it. And use the same code here. But you have to be careful. Why you have to be careful? Because here I'm making if statement for register A. But for if the question you want to make it for register D, it's going to be the same thing. But instead of saying compare A, I'm going to say compare D. That's it. That's what I'm saying. Here, I make, or if the condition here, guys, is greater, it's not about equal. You can use the same logic, but you have to use a different branch. So, for example, if it is greater, what I would use here, use greater. Okay? So here, that's what I have: greater or equal or greater. So instead of equal, if I'm saying if this one is greater, if it is greater, so you can use here greater, or you can use higher. You can this one or this one instead of not equal, right? Or sorry, you can use. Okay, that's good. Let's go. So if it is I greater than 2, right? That means I want to jump here. If A or I, okay, is not greater than 2, right? And I want to come to here if I is greater than 2. Is that okay? So here I want to do the opposite of the condition. What is the opposite of greater? Less than or equal. Let's say it again. Look at what I'm saying. I want to change this condition from equal to greater. Is that okay? Similar to what I did here. What I did here, I used the opposite of the condition. Here not equal. So the condition is false, come to here. But then do the same thing. So if this is green, it's green. So here I have to say if it is not greater, come to here. But do we have condition for not greater? Yes, less than or equal. Right? Not greater means less than or equal. So what I'm gonna do here in this condition, I'm gonna say less than or equal, come to here. So this greater than or equal. You understand what I'm saying? I'm going to give you more examples. I consider Honestly, I consider this topic the most difficult topic in this course. I consider this one because maybe it's not, it has some logic you should understand it. But it will be okay. I'm going to spend enough time with this one. We're going to have a lab. We're going to have a quiz. Okay. We're going to have assignment on this topic as well. So don't worry. Everything will be good. Okay, guys. Let's have something. Let's have something like that in C language. Okay, but again, I'm going to teach it in C before I teach in assembly. I want to do something like that, guys. If A is equal to 1 and remember this end, B is greater than 8. This is what we call compound condition or complex condition, right? So what I explained here, it was only one condition. So what I explained so far, it's one condition. Sometimes you can have more than one condition, right? So like this example in C language, I'm teaching C language. I just want to explain the logic in C, and then we're gonna see how can we mix the same logic in assembly, okay? C and C, okay? So let's teach it in C first, okay? So if A is equal to 1 and B is greater than 8, we're gonna execute S1. So what the C language is telling us here for this statement? This statement is telling us execute S1 if A is equal to 1 and B is greater than 8. So I have two conditions. In order to execute S1, the two conditions have to be true. Both of them should be true. Is that okay? Instead of one, I have two conditions. Both of them should be true. So if the first condition is true and the second condition true, so you have to execute S1, right? Okay. Look here, guys. So I can make assembly based on this logic, or I have the same logic but in a different way. And I think this different way is better for assembly. It's going to make the assembly easier. So let's see what is the other way. The other way is, as you see here, look here, guys. Don't execute S1 if A does not equal 1 or B does not equal 8. So here, look what I'm going to do. Maybe this logic is the same logic as this one, but it's going to make the assembly better, easier. So less number of instructions. Again, you can make the assembly based on this logic, you can make it based on this logic. This is programming, right? But by the way, if you do this way, you will use this number of instructions in assembly. So the logic here, look here, guys, what I'm going to do. I'm going to check the first condition. If the first condition is false, so don't do this one, skip this one, right? If the first one is true, so I'm going to check the second one. The second one is false, skip it. I'm going to show how I made it. So look how I made it, guys, using this logic. Again, you can program it using this logic, but I think this one will make it easier. Look how I made it. I'm going to compare it to 1, and then I'm going to say branch it to if not equal to end. Oh, so I'm going to check the first condition. If the first condition is false, false means not equal. If it is not equal, go outside. I'm done. So I went outside here. I skipped this one. Skip it. Now, if this branch is not taken, and I come this way, what it means? It means A is equal to 1. It means the first condition is true. Is that okay? So if the first condition is false, so I'm going to branch it to B. And then I'm done. I'm not going to execute this one, right? If the first condition is true, so the branch is not going to be taken. I'm going to come to here. So if I come to here, what it means? If I come to here, so the first condition is okay. So now let's check the second condition. Well, first condition is true. So now let's look at the second one. So for the second one, I'm going to compare B to 8. I'm going to compare to 8. And then I'm going to say here, less or same. Less or same, the opposite of this condition. Less or same. So I'm going to say if it is less or same, okay? So that means the condition is false. It means B is not greater. It's not greater means less or same. So I'm going to skip to here, okay? If so, quickly, let me say something here. So if it is greater than 8, so I'm going to come to here. The branch is not going to be taken, okay? Let me. I'm going to repeat what I said, but maybe in another way. Okay, look what I'm going to say. I have two conditions. If the first condition if the first condition is false, so I'm going to skip to here. Okay, I'm going to skip this one. Okay, now otherwise I'm going to come to here. If the second condition is false, I'm going to skip. So the only way to arrive to here, the only way to come to here, the two branches should not be taken. And the two branches are not going to be taken if the two conditions are true. Okay? Because if the first condition is false, I'm out. If this one is false, I'm out. Okay? So if these two branches are not taken, any one of them is not taken, that means the two conditions are true. Is the logic is that okay? Think about it a little bit, okay? Okay, guys, so okay, so try my advice to you guys, please. I consider this topic the most difficult topic I'm going to teach in this course. Please try, at least try to read it today, not tomorrow. Try to go through it today before you forget what I taught here. I'm gonna post, I can also post the video online, but try to study it today. Okay, we're gonna have a lab on this topic next week. So please try to put some time on this. This is important topic, and I think it's one of the most difficult topic I'm gonna teach in this.